Right. Score 2.6. It's basically just graphing. It's nothing crazy, but what I want you to know or have these printed out somewhere, um, these are the parent functions. Okay, so linear functions always have a slope, and if it doesn't, then it's a constant function, so it'll be horizontal. So y equal to a number or f of x equal to a number, a constant, hence constant function. The famous line y equals x or f of x equals to x is the identity function as well, because no matter what you plug in is what you're going to get back. We got our quadratic, which is the parabola. Got the cubic, which is this little weird s thing. Square root, cube root, absolute value, and the 1 over x, the reciprocal. So I want you to remember what they look like or have this printed out for your notes because this whole entire section is just can you transform these into uh, either a stretch or a compression, either blow up the graph, move it down to the left, flip it over, that type of stuff. So in order to do so, you need to remember what they look like. So check this one out. This is clearly a constant function, right? If you look at number one right there. So where is it at? It's at the one. So it has to be y equals to the one or f of x equals to one. That'll be my graph. This is a square root type for sure. So it's not going to be any of these or any of those. There's only one square root type, right? So I'm just using this fact that it has that kind of shape right here. So if you already knew that, then this would be easy. And if you don't, you gotta look at the graphs. Okay. All right, now let's see. This next one. This looks like the reciprocal function. So it's gonna be okay. So this is the reciprocal type. Just from memory, I know it's going to be number eight. And the only one that I see looks like this one. This is the cubic type, just from memory. So look at all your graphs, and that's it. Now the next thing, again, I would recommend putting all these like on formula cards just so you don't have to memorize it. But basically, if you have a function and you add a number to it, some number k, or subtract that by a number k, you're going to do a vertical shift. So it's going to move upward k if it's positive, downward k if it's negative. If it's inside y plus k, then it's going to be horizontal shift. Actually, sorry, this one. X minus h, x plus h. So this is opposite. So if it's positive, it'll go to the left. If it's negative, it'll go to the right. Although when it's straight up, on the outside, it's up and down. And here's some ideas to help you remember that it's going to shift all the y values. So there's a tip here. And this one is going to shift horizontally in the opposite direction, which we already said. Yeah. Okay, now consider a function defined by y equals f of x. Let a represent a positive real number. So if the a on your function, of your parent function, right? Let's assume it's one of these, like the number in front of your function, your a. So this is a one. These are all ones right now. But let's say that one was negative. If it's negative, it's going to create where is it? If it's greater than one, actually, before we get to negativity, if it's greater than one, it's going to stretch by that factor. So it's going to be stretching. Now, if it's less than one, so if it's a fraction, it'll be shrunk vertically. We'll show that picture in a second. Okay, now if it's inside, it'll be a different kind of shift. Um, this will be a shift, or sorry, it'll be stretched or shrunk horizontally by this number. So it's bigger than one, it's going to shrink horizontally. If it's a fraction, it'll be stretched horizontally. I don't expect you to memorize all of this, um, but have it in your notes from your formula cards. Now, this is what I thought they were talking about. If the a in front is negative, it'll flip the graph down. So if it's a parabola, the x squared, if it's negative x squared, it'll flip down. Positive will be up. If the negative is inside, though, it'll flip this way. But a parabola you can't tell because it's an even function, so nothing would happen. I mean, it would technically flip, but it'd be the same thing, right? You end up with what you started with. So here's like a big summary of all the ideas. It's kind of cool. But here, let's get started. So here's the original. So absolute value of x is this one here, the OG parent function. So they want us to transform it or translate it into this here. So let's open the grapher. Okay. So I believe the grapher's on the screen and double check here. We'll call it y, not faded. So there's the original that they have. Now let's do piece by piece. If I do plus 4, the outside, notice how it shifts the original up 4. If I do minus 4, obviously it goes down 4. So that's what the property I was talking about. In this example, they're doing two things at once. So let's do that part so you can see it. The blue one, that's what it does. Now, if it's inside, it'd be x minus 3. To check out, let me block the blue one. The original is there. So if it's minus 3, it's shifted to the right 3. So it's always opposite for the horizontal shift. Now, if you do both at the same time, right? It's a horizontal shift and then a vertical shift. So piece by piece, right? The original shifted up 4 if it's outside, shift to the right 3 if it's inside, and negative. All at the same time, it's 3, then 4. So this is what they want us to graph. Okay, so you can use graphers or your graphing calculator, but what I want you to understand is where do they shift and why? Like more of the concepts, not graphing by hand necessarily. It's like just remember, right? What happens if it's out here? What happens if it's in here? That's what I want. Okay, so let's go back to the PDF here. Okay, so this is a negative 3 out here. We said if it's greater than 1, it's going to do a vertical stretch, I think. Gotta look it up again. Plus two, we said that's a vertical shift. So let's, and then the minus five is a horizontal shift to the right five. So they just want us to do all this here. Okay. Okay. So piece at a time, right? These are from the last question. Let me get rid of them. That's the end result we're going to get, but just so you remember, that's the original. If you put a negative 3 on this guy, it shifts it, reflects it down, and then stretches it or shrinks it vertically. Okay, now if you put the minus 5, it moves it to the right 5. And if we have the 2, it shifts it up 2. So, yeah, this is the answer, but I want you to understand why that's the answer. So let's go back to the PDF. PDF again. So right here, this is a parabola, right? This is a quadratic type. So remember, if you don't remember the parent functions, you'd have to look it up. What does a quadratic type look like? And then remember, what does the minus 2 do? What does the minus 3 do? We know that this is a vertical shift down 2, and this is a horizontal shift to the right 3, right? So if you were to sketch it, you would just say, well, to the right 3 is right there, up 2, no, down 2. So it'll be like something like this, whatever. Okay, so that's the same for cubic. All these ideas will apply to any function. It's just that each one will look different, and you have to remember what they look like. Okay, so number 6, they have a parabola and they want us to translate y equals x squared, x plus 5 squared. So we should remember that this means a shift to the left 5. So you would just graph this or sketch it on paper and say, well, it's going to move to the left 5, and it's still a parabola. So it would be something like that. Part B is like, okay, well, it's outside, not inside. So it would be going down one. So it'd be here. Something like that. Graph it on your calculator. You're just, you'll get something, I mean, something way prettier. That's awful, actually. Whatever. But anyway, we're just moving the parabola around, remembering what vertical shifts, horizontal shifts do. So the next one, they're doing multiple at the same time. Plus 4 inside means to the left 4. Minus 2 means down 2. So you just have to remember, what does this mean? So look at the notes. What is the shape? Well, they told us, so that's easy. And then move it appropriately. But that's pretty much it. And you can use your calculator, like I said. I'm not going to try to force you to do this by hand, really. This is more about concepts. Do you understand the why? Okay. So here, just real quick, I guess, before I end this section, if this is inside, then that means it's going to affect all the x values by 1/2. So if you don't know the function, you just know the general shape. You know the shape, but not the graph. But if you know you're doing this to the actual original, that's going to be uh, all the x values be shrunken down by a half. So all these x's that these are plotted on. So you would pick some points. So let's say this is the original, and then the new one, we'll call it x prime, I guess. We have a point at 4 or 0, 0, right? So that means that if I put a half in here, it would be times 0. So still 0. 1, 1. So at 1, this would become a half. So all the values would shrink. At 2, this would become 1, and so forth. So then just graph accordingly. Just shift everything or uh, shrink it. Let's do an example so you can see it better. 'Cause it's kind of hard to see with this. Let's do a visual. So let's say you have the original right there. And then we say, well, what if those y equals half 4.5 x. There we go. So I always get the terminology backwards. That's like stretch, compress, stretch this way, or compress this way or this way, depending on the context, right? To me, this looks like it was stretched this way, but I guess you could say maybe it was compressed downward. But anyway, who cares? You can see that all the values are cut by a half. Let's see, is it a pretty number or not? 5, 5. This will be 5 and 2/5, 2.5, 0.5. Oh, shoot. So the x's stay the same. I had it backwards. My apologies. All the x's are the same, but you're cutting the output in half. So the x's will come in as normal because if you look at the number 11, it's still f of x. It's just you're inputting a half. So the x's that go in don't change. It's just the outputs change. So that all the outputs are cut in half. So instead of having 1, 1, right, like this guy, you'd have 1.5, 1 and zero point 0.5. See, that's all. But it helps to graph so you can see and remember. But it's also in all those notes that were up top on the PDF. Right, this should double your graph. And then they say, okay, well, what happens if we double and then do +1? And so you just gotta start understanding the general ideas. So this is when the conceptual stuff kind of hits. Okay. Anyway, let's look at the answers real quick. Forgot they're in here. We know if it's outside, that's a vertical reflection based on the notes. If it's on the inside, it's a horizontal, a reflection about the y, a reflection about the x. Is how we should say it. And here's a half. So the x value should be the same. 1, 1, 2, 2, 3, 4, 5, 6. Give us that stretch we showed on the graph. So yeah. Anyway, like I said, I don't want you to spend too much time on graphing these by hand. It's just Remember these concepts, understand what does vertical, horizontal shift, reflections, and you should be good for the most part. You can use your calculator to answer the homework and to run your exams. I just need you to understand how do they transform and why. Okay, let's move on to something else.